Hi there, this is your favorite math learning channel, and I have a divisibility problem for you. Well, it's really hard to say divisibility, but I managed it. Cool. So we have that 3 to the n minus 1 plus 5 to the n minus 1 divides 3 to the n plus 5 to the n. This is actually not true in general, so we are asked to find for which values of n this is true. Also, I should say that, well, obviously, since we are asked for divisibility, all of these numbers are just integers, so maybe I should also say that n is just greater or equal than 1. Okay, cool. So basically, n is just an integer, positive integer. So let's see, well, I know that, so this thing just divides this thing, so I'm assuming that n solves this equation. So I know that 3 to the n minus 1 plus 5 to the n minus 1. Let's try to write something in general that this thing would just obviously divide, and I will try to make that thing look like 3 to the n plus 5 to the n. So let's see how we can do it. Well, if I multiply this equation by 5, obviously this is going to be true, because what I mean is that, for example, if n divides k, of course n divides 5k, because it's just even bigger. It divides even better. So here I can just multiply this equation by 5. 3 to the n minus 1 plus 5 to the n minus 1. And this is going to be true. So if I just open this, it's going to be 5 times 3 to the n minus 1 plus 5 to the n. Why did I do this? Because now I got 5 to the n. And I actually almost got 3 to the n too. So if I just separate this 5 as 3 plus 2, from this part I will get a 3 to the n too. So I can just say it's 3 to the n plus, let's group them together, 5 to the n. And then I just have plus 2 times 3 to the n minus 1. Also, another divisibility property, that if I have, like, let's write it here, if n divides k, and if n divides, let's say, l, n would divide any linear combination of these two. So this means that if n just divides them, for example, n would divide 2k minus 3l, n would just divide minus l, n would just divide k plus l. Okay, it goes like this, and therefore I can say that since it divides this thing, this left hand side, and it also divides this thing, I can just subtract them, and I can say that this thing, 3 to the n minus 1 plus 5 to the n minus 1, divides 2 times 3 to the n minus 1. Okay, but now it looks actually a bit sketchy, because I know that anything, if n divides k, n has to be less or equal than k. We can say absolute value of k. But here, if I look, okay, 3 to the n minus 1 is that, but I can just say that, so obviously 5 to the n minus 1. So I'm claiming that actually 3 to the n minus 1 plus 5 to the n minus 1 is just greater or equal than 2 times 3 to the n minus 1. Why is that? So, well, there are two ways to show this. I actually would like to show this with analysis way, but there is a much simpler way. So yeah, I'm not gonna use any analysis on this video. But here I can just, so I'm checking that, is this true? Well, this is true if and only if. So I can just send this to the right hand side. Well, normally you can't really assume that this thing is true and you can do stuff, but if you use if and only if, this is valid. Okay, so you can just send this to the right hand side. So this gives you 5 to the n minus 1 greater or equal than 3 to the n minus 1. And now, so I know that in general 3 to the n minus 1 is just positive, so I can just divide all sides by 3 to the n minus 1, and equality won't change signs. So it will be 5 over 3 to the n minus 1 greater or equal than 1. And, well, is this true? Obviously, because n is greater than 1. So I can just take log of all sides. Log 5 over 3 is not 1, so I can just take log of it. If I take log, it will be and logarithm is an increasing function, so equality again won't change signs. So it will be n minus 1 times log of 5 over 3 is greater or equal than, so log of 1 is just 0. So, well, this thing is 5 over 3 is bigger than 1, so log of 5 over 3 is just bigger than 0. And so therefore this thing is also just bigger than 0, because it's bigger or equal than 0, because we said n is greater or equal than 1. So therefore this thing is true. Well, here there are two ways. You could just write on your paper that, for example, you could just try to like be more cool, and you could write on your paper that n minus 1 is greater or equal than 0. This is obviously because n is just greater or equal than 1, and then you could just multiply all sides by log of 5 over 3, and then you could go here, and then you could go here, and then you could just go here, and you would say that, oh yeah, this is true. Okay, so well, it's useful. And well, you could just also obviously say that 5 is greater than 3, so this is true. Okay, I just wanted to make it like a bit more solid. So here what we found, that something that divides something, so n divides k, but n is bigger or equal than k. Well, this is not possible. Okay, this is a I forgot the word. This is a contradiction. And so therefore we can say that this is not going to hold. But here let's also check the value when n is equal to 1, because if you look here, we have the equality satisfying if n is equal to 1. So this equality can actually satisfy if n is equal to 1. So if I put n is equal to 1 here, I will get just 3 plus it will just be 1 plus 1, and if I put it here, so this does it divide 3 plus 5? Yeah, 2 divides 8. So this is actually true for n is equal to 1, but anything bigger than that will not satisfy this thing. So it will satisfy this thing, but it shouldn't satisfy this thing. So I will know that there is no solution n bigger than 1. So we find that our answer is just capital 1.